back to another section of today's video. Now we're going to be talking about introduction to 3D vector analysis. Okay, now 3D vector analysis simply means three-dimensional vector analysis. Now what we do in this case is a case of vector in which we're not just dealing with the linear component of x and y, but rather including a third component, which is the z-axis, okay, or the k-axis. Okay, so we'll have ij and k, we also have x, y, and z. So we're not having three components in this case. Now, how do we resolve vectors? This is an introduction to 3D vectors. Okay, so the first thing I want to learn is how we resolve vectors that are in a 3D form. Now, I'm going to draw a diagram here. Okay, and that diagram, I'm going to show you how vectors are resolved when they're in 3D form. Now, there are two cases, of which I'm going to call the first one case 1. Okay, now for case 1, let's say we're having a cube of this form. Let's say we're having a cube of this form. Okay, and then we're having a vector. Let's say the vector is like this. Okay, now in this case, we're going to assume the vector is having an angle. I'll call this z-axis, I'll call it the x-axis, and I'll call it the y-axis. We're going to assume the vector is having an angle, which I'm going to call gamma to the z-axis, okay, and then having an angle alpha to the x-axis, and then an angle beta to the y-axis. Now, resolving this into the various components is quite easy. All we have to do is resolve directly using cosine function. Okay, now to resolve to the z-axis, I'm going to have, if the vector is a force, for example f, I'm going to say f of z is equal to f cosine of gamma. Okay, now f of x will be equal to f cosine of alpha, and then f of y will be equal to f cosine of beta. Okay, this is basically what we're going to get. Now, how do we now find the single vector that will act like these other vectors acting together? These are the various components. Now, please take note that just like the 2D vector, okay, of which to get the resultant vector or mix of the Pythagoras theorem, we do the same thing here. So to get the resultant vector, which I'm going to call f with a subscript of big R, that will be equal to the square root of f of z all squared, okay, f of y all squared, and then f of x all squared. So it's very, very easy to comprehend and understand. All you have to do is resolve to the various components if the angles are given directly to these components. Now, how about a case like when we have something like this? Okay, how about a case like when we have something like this? Okay, now in this case, here is going to be I'm going to draw the vector like this. Now this one is also having an angle, okay, but in this case the angle is let's say with the z-axis, this is z-axis, this is the x-axis, and this is the y-axis, and the angle here I'm going to call it gamma. Okay, that's the angle with the z-axis, and then we're going to have a bottom like this. Now in this case, we cannot just resolve to the x and y-axis because we are not giving the angle here, okay, but we're also giving the angle with this center, this diagonal, okay, and also we are giving the angle between this one to be better. Okay, now what we're going to do first of all is resolve down to this bottom component, which is diagonal. Now when we do that, I'm going to resolve it and call it f prime first. Okay, so if the force or if the vector is a force f, okay, so resolving to the components, we're going to get f prime to equal f. Now I'm opening this and breaking into the bottom, so we're going to get f sine of gamma. Okay, now to get the z-axis the same as the first one, since we're having the angle directly, we just close it. Okay, so that becomes cosine. So for the z-axis, we get f of z to equal f cosine of gamma. Now, how am I going to get f of x and f of y? Now, to get f of x and f of y, this one which is not lying on this plane is f prime, because we have resolved this one into this plane. The next one I'm going to do is resolve this one into the x and also the y components. Okay, now to do that, we're going to get f of x is equal to f prime, okay, which is f prime cosine of alpha. Okay, that's what we're going to get, cosine of alpha, or we could as well write it as f prime sine of beta, because it's either we're closing this angle or we're opening this angle. Remember, alpha plus beta sum to what now 90 degrees, they are complementary. Okay, so I could write 90 plus beta here, which is same as sine beta, or I could write 90 plus alpha here, which is same as what now, cosine of alpha. Okay, now how about to simplify this further? We're going to get f of x, okay, or f substitute s rather. We're going to substitute f prime as f sine of gamma. So that gives us f sine of gamma cosine of alpha equals f sine of gamma and multiplying sine of beta. Okay, so basically all you have to do is understanding how we resolve. We have to resolve first of all to this plane and then closing it down to x. Okay, and then also after resolving to this plane, we then close it down to y. Okay, just to make sure we get the f of y and then the f of x as well. Okay, now the next thing we're going to find is the f of y. Okay, what's about f of y? We've already resolved to this plane, that's f prime. So it's either we're opening this angle alpha or we're closing this angle beta. Okay, so when I open the angle alpha, if I should open the angle alpha, I'm going to get fy is equal to f prime, okay, which is f prime, that's multiplying sine of alpha, we're opening this angle, okay, and resolving into this plane. Or we could as well write f prime, okay, times closing the angle cosine of beta, cosine of beta. So depending on the position of the angle, that will determine how we're going to resolve, okay, whether we're using alpha or beta, or we could as well subtract from 90 before resolving. You don't have to come any of these formulas. All you have to do is understand the principle behind this case, okay, behind resolving vectors. Okay, so if I simplify this one further, I'm going to get fy is equal to, now f prime, which we've obtained before, is f sine of gamma. We have f sine of gamma multiplying sine of alpha, or we could as well have f sine of gamma multiplying cosine beta. Okay, now to find the resolved vectors for this case, it is still the same thing. So automatically we're going to have fr equals square root of fx squared plus fy squared plus fz squared. Okay, so basically we're having the same thing. Okay, mind you, the x, y, and z components remains the same and they correspond to the I, j, and k. Okay, they all correspond I, j, and k rather. So we have I, j, and k. Okay, they all correspond to one another. So if you are seeing I, j, and k instead of x, y, and z, you should know that respectively I is k, I is x rather, j is y, and then k is z. So basically this is an introduction to how we resolve vectors when we are dealing with three-dimensional vectors. Okay, now in our next video we're going to go fully into taking questions on how these things are being done. Okay, how we resolve questions or examples on 3D vectors. So what you might want to do for now is practice these things and understand it better. You can choose to go over the video one or two times, and if you have a question, put it in the comment section and then I'll respond to it. Okay, or if you have a video you want to talk about still on these mechanics. Okay, so I'll go over everything again. For a case like this, when we're having the angles to the z components, x components, and y components directly, we just resolve. So for the z, we have f cosine of alpha, f cosine of gamma, and f cosine of beta. Everything remains cosine, okay, most times. And then when we're having the angle just to the z components and we're not giving that to the x and y component directly, we might have to resolve to a bottom plane, okay, of which when I resolve it lies on this plane, assuming, okay, and the angle will be given alpha and beta. So what we want to do is we resolve the one along the plane first, which is what I called f prime, and that's given as f sine gamma by opening this angle. Okay, now f is equal to f cosine of gamma. Okay, f of z rather is f cosine of gamma, that is when we close this angle. And then for x, this one line on this plane we resolve to this side, or we make use of this angle using sine. Okay, so if you make use of this angle with sine, you make use of this one with cosine, and then substitute for f prime, you get this. Okay, and for y, f prime sine of alpha, by making use of this angle, opening it, or you make use of this angle, that's cosine. Okay, so by substituting f prime, you basically get the same thing. So if you have a question, like I said, put it in the comment section. Do not forget to like and share this video. Also subscribe to the channel, Dr. Flash, and put on your notification bell so that when a new video has been uploaded, you get you'll be one of the first few persons that get notified. Okay, and in our next video, like I said, we're talking about more on 3D vector analysis. I will take a few questions. Okay, now stay tuned. See you in the next video.